Everyone, myself Avni Verma, and I am pursuing CSC with AI and Data Engineering with Future Ends from Lovely Professional University. And today I'm going to explain the topic on binary trees. And I'm also going to explain how to take out the transversals of binary trees, and I will also write the code for that. So if first of all let's start a binary tree. So what is a binary tree? It is a type of tree data structure where each node can have a maximum of two values, means two child nodes, a left child node and a right child node. So here if we see in this diagram, so for this one as a parent child, we have two child nodes as 7 and 9. And for 7 we have two child nodes 2 and 6. After this, but here we have a restriction that a node can have a maximum of two child nodes. So this have many benefits. For example, like algorithms like transversing, searching, insertion, deletion become easier to understand and to implement and run faster. Second benefit, we can say that keeping data stored in a BST means binary search tree, which makes searching very efficient. And it also helps in balancing trees. For example, using AVL binary tree, for example. And binary tree is also represented as arrays, making the tree more efficient. So, first of all, here restriction is that we can keep only 0, 1 or 2 child nodes, not more than that. So now here are some terminologies. Parent node. So what is a parent node? We can also say this as internal node. So parent node in a binary tree is a node with one or two child nodes. For example, if you understand with an example, so here 1 is a parent node for 7 and 9, and 7 is the parent node for 2 and 6, and 9 is for 5. So basically we can see here it have two child nodes and here it have one child nodes. It can have 0, 1 or 2 but not more than 2. After this, now let's talk about tree height. So what is tree height? It is the maximum number of edges from the root node to the leaf node. Basically, what is root node? Here root node is 1. The uppermost node is root node. After that, the end nodes are known as the leaf nodes, which do not have any child nodes. Now let's talk about that why we are studying binary trees instead of arrays and linked lists. So we are studying binary trees as arrays are faster when you want to access an element directly, like element number you can say 700 or 1000 elements for example, but inserting and deleting elements require other elements to shift in memory to make place for the new element or to take deleted elements place, and that is so much of time consuming. For example, what is saying that, for example, we have some elements here. So for example, we can take 5 elements. So we have 5 elements and we want to shift this element, fifth element, here in the place of the third. So this third element and then fourth element will shift one place upper in the array or the list. So it will take so much of time in this shifting process. So for saving our time, we use binary trees. And if we talk about linked lists, so linked lists are fast when inserting or deleting nodes, but it also has some condition that linked list must be traversed, and that takes so much of time. So we use binary trees like such as BST and AVL trees. They are great compared to arrays and linked list. So basically if we talk about BST and AVL, then binary trees are the base foundation for BST and AVL. And now we have some types of binary trees. For example, balanced binary tree, complete binary tree, full binary tree and perfect binary tree. So what is a balanced binary tree? Tree that has at most one indifference between its left and right subtrees heights for each node in the tree. For example, here we can see that balanced tree here. It has difference of 1 between its left and right node. For example, here 1 and 2, and here also 1 and 2. So it contains one difference between its left and right subtree heights for each node. Now what is a complete binary tree? We will also discuss some from things from the diagram. For example, here binary tree, it is containing, for example, this is left subtree and this is right subtree. So between this we have a difference of 1. Now, what is a complete binary tree? A complete binary tree has all levels full of nodes except the last level, which is can also be full or filled from level left to right. And so, properties of complete binary tree means it is also balanced. So, it is a major point here that complete and balanced binary tree means here all the levels of this trees are filled with nodes except the last level. As we can see in this diagram, here the level is filled, here the level is filled, but here we have incomplete level as it is the last level. So it is fulfilling the condition for complete tree. And if we talk about balanced tree, so here balanced condition is already fulfilled, that it has a difference of 1. Now next if we see here, then we have full binary tree. So it is a kind of tree where each node has either 0 or 2 child nodes. Like in binary tree there should be 0 or only 2 child nodes. It cannot be like one child node. So it should contain 0 or 2 child nodes. After that, let's talk about perfect binary tree. So what is a perfect binary tree? So it has all leaf nodes on the same level, which means that all the elements are full of nodes and all internal nodes have two child nodes. So the property of a perfect binary tree means it is also full, balanced and complete. Now let's understand this topic with the help of diagrams. For example, here full tree. So what is the condition for full tree? That full tree means that it should have 0 or 2 child nodes. It could not have one child node. So here we can see it have 2 child nodes. Here it have or it can have 0 child node. For example, 7 have no child node and 11 have 2. But here we cannot see only one child node. Now if we talk about perfect tree, then it is fulfilling the condition for full and balanced and complete. Here we can see full means only 0, it can have 0, so 13 have like here leaf nodes have 0 child nodes and or 2 child nodes. And balanced also, like it between right subtree and left subtree there is a difference of 1. And complete also, that their all levels are completed with nodes except the last level. So this is known as a perfect tree. Now, let's talk about the binary tree traversal. So, tree can branch out in different directions, means non-linear. There are different ways of transversing trees. So, there are two main categories of tree transversal method. So, if we talk about three main categories, so there are different types of traversals: pre-order, in-order, and post-order. So, now let's understand the concept of this. We will come to this question after the understanding of this concept. So before understanding the traversal part, let's first understand that how to insert an element into the binary or delete. So for deleting, now first what are the steps for deleting an element from a binary tree? That starting at the root, finding the deepest rightmost node in the binary tree and the node which we want to delete, then we will replace deepest rightmost node data with the node to be deleted. After that, then delete the deepest rightmost node. Now let's implement this. So first of all, first question is that we have to delete 10 in below tree. So for deleting 10, what we'll do is that simply we will start choose the rightmost node. Here the rightmost node is 30 and the element which we have to delete, we will replace our rightmost node in place of that. So we have replaced this 30 in the place of 10. So now our 10 is node is deleted. Now we can take one more example, as here we have to delete 20. Now what is the rightmost node here? That's 40. So we will just delete 20 and replace 40 in the place of 20. Means now the 20 node is deleted. Now how to insert? Now here we have to insert 12 for example. Simply what is the ideology for this is that we simply have to empty the nodes, else if we find a node whose right child is empty, so we will keep it there. Basically at the place of empty node we can keep our new node, we can insert that. So this is the concept for inserting. For example, if we understand with the help of example, then here we have to insert 12. So between here we can see there is an empty nodes, empty child node, so we can just insert 12 there. Now let's understand the algorithm for in-order traversal. So what is in-order? means how to do this means first of all we have to traverse the left subtree, that is we will call in order means left subtree. Now we will visit the root. After that we will traverse the right subtree, that is called in order right subtree. Now what is there in this? Let's see. So here in-order traversal binary tree means initial traversal from root to leftmost node. Means root is here is 1 and leftmost node is 4. So what we'll do is that 4 we will start from here 4, after this we will write 2 then 5, so like this 4 2 5. After that we will not directly come here, we will come here from 5, we will come to the root node means 1. So now 1, then we'll go to 3, then we will go to 6. So this is the basically here root node 1 is the initial traversal from where we have to start from the leftmost, then we have to go to the middle one means root node, after that we will go to the right. Like this we can take out the output for our in order traversal. Now if we talk about the algorithm for pre-order traversal, then what we'll do for that, we will visit the root again here, this one, then traverse the left subtree means this subtree, and then we'll call pre-order left subtree, then we'll transverse the right subtree, that is called the pre-order right subtree. So what basically we are doing here is that we will simply start initialize from this root node means 1, then we'll go to 2 and then 4. Now from 4 we will not go to 1, we will go to 5. Like in the previous one we are going to the root node, but here we will go to 5. After this we will go to we will not directly go to 6, we will go to the next rightmost right subtree means 3, and then after that rightmost node means 6. So like this we can take out the output for pre-order traversal of binary tree. Now we will see algorithm for our post order traversal. So what we are doing here is that we will just traverse the left subtree, that is called post order means left subtree. Now we'll traverse the right subtree, that means that is we will call right to subtree, then we will visit the root. Now if you notice here, then in the previous two topics we were starting initializing from root node, that is 1. Now in this post order we will visit to our root node in the very last situation. Now let's start. We will initialize from root to leftmost node means leftmost node is 4 here. So we will start from here to 4, then we'll start from 4, after that we will go to 5. After that we'll go to 5 means we will first of all will cover the leftmost subtree, then we'll go to 2 as it is also coming in left subtree. After that we will not go to root node, we will go to the rightmost subtree, that is 6, and then it will return to 3. After that it will at last it will visit to the root, that means it will go to 1. So basically this is post order traversal binary where we are visiting to the root at the very last. So basically now let's go to the coding part. So let's now come to the coding part, means now we'll start with class tree node. Basically we are coding for pre-order, post-order, in-order for the binary trees and how we are going to take out the output for that. So now tree node, then we will define and initialize our function. Init uses to initialize self values self value. After this self dot value equal to value self dot left. So here first of all we are taking left part, none. After that, self dot write. After that, we are going to write none. Now what we have to do here is that we will just define, first of all, we are doing in order. So, in order traversal node. Now, if node in order traversal node dot left, node dot left. Now after this, we will print node dot value, node dot value, then end equal to, give a space between them. After this, we will print, after this we will print in order traversal, in order traversal for right node. So node dot right. After this, we will define for, now first of all we have defined for in order, now we'll define for post order. So define post order traversal node. After this, now we will use if function, if node, as we are using condition here. So if node post order traversal, post order traversal left node, for left node we will write left node dot left, then post order traversal, for right node we'll write node dot right. After this we will just simply print the node value, and then we will end this, end equal to, now we have already printed here for post order traversal. Now what we'll do is we will come to the pre-order. So now after doing this, we will define pre-order traversal node. After this, again we are going to use if function. Now we will simply print node value, node value. After that, we will end this, Now, now we have print pre-order. So now we will write pre-order traversal left node. So we'll write node dot left. After this, we will write pre-order traversal for right node. We will write node dot right. Now Now let's see. So basically, this is the basic code for our implementing in order, post order, pre order for a binary tree. Now we will see the example usage. So let's make a comment. Example usage. Now let's start doing. Now we'll construct a sample for a binary tree. So here we will write root equal to tree node. That is, we will take 1. Why we have taken 1? As root is 1 here in our sample tree. Now, tree node. After this, for left node, we are taking the values root dot left equal to tree node as 2. It means that our left root, leftmost value is our 2. For left subtree. Now we are taking root dot right. It means now we are taking the value for rightmost value. Now tree node, that is we can take here 3, and then next we will take root dot left means left value of the left subtree. So here we are taking it as tree node. We can take it as 4 as a value. Now we'll take root dot right root dot, we will take here left dot right, means left value of the right subtree. So now tree node, let's take value for this as 5. Now we will just simply print the value. So print, first of all we will write in order traversal like this. After this we will write here in order traversal, now here root. Now in order traversal after root, after this we will just print let's n. Now what we'll simply do is, now we will print for now first of all we print for in order. Now we'll print for the post order. Print post order traversal now post order traversal root. After this we will again do print like this. Now we have printed for in order, post order. Now we'll print for the pre order. So let's do it. Print pre order traversal. Now we will write pre order traversal route. So now we will print it for the pre-order traversal. So in order, post order and pre-order. So now before running the code, we'll just simply check our code. First of all, we have defined the init function is we have initialized it. Then cell dot value after for right node and left node. After that, first step was to print for in order traversal. So for we have printed for right node and left node, like no dot left and no dot right. After that, for post order we have used again if condition, then post order traversal for left node and right node. After that we have printed the value. Then for pre-order again we have done that left node and right node. Now we have seen example usage here. For root is equal to tree node. Basically we are imagining a tree here whose root node is 1 and whose left value is 2 and right value is for 3 and left value of left subtree is 4 and left value of right subtree is like 5 or so basically these are all the values for us. So now after that we have printed for in order traversal, then post order traversal and then pre-order traversal. Now let's run our program. So basically these are the values for our in order and post order. So here these are the values for our in order, mean basically 4 2 5 1 3, post order 4 5 2 3 1 and pre-order traversal 1 2 3 4 and 5. So these are the values. So now this was the thing. Thank you.